Alright, so in those warm-up examples, we have our solving and graphing of absolute value equations or inequalities. So what we wanted to do was to isolate the absolute value if it wasn't already done. So in that case of the first problem, the absolute value is isolated. You have 5c equals 20. So then you have to split your absolute value. So since 5c was equal to 20, you split it into the positive and the negative. And then you solve for c. So you get c is equal to 4 and c is equal to negative 4. So those two values are my possible values. With absolute values, you have to check to make sure they're not extraneous solutions. So you just quickly put 4 back in. 4 times 5 is 20. Absolute value of 20 is 20. Negative 4 times 5 is negative 20. Absolute value of negative 20 is 20. So number 1 checks. We're good. We're happy. Number 2, you have absolute value of 2 minus b equals 10. So same idea, you split it into the positive and into the negative. And then you solve for b. So we subtract 2, divide by negative 1. And then over here, same idea, subtract 2, divide by negative 1. And check that back in. So 2 minus a minus 8 becomes 10. Absolute value of 10 is 10. 2 minus 12 gives negative 10. Absolute value of negative 10 is 10. So it checks. Now, number 3 is an absolute value inequality. So absolute value inequalities are when we used to say an absolute value is great or less than. So since this is absolute value of 2h is greater than or equal to, it's a great or. So that means we're probably going to go in opposite directions. So you have 2h is greater than or equal to 8. And 2h is less than or equal to negative 8. Solving for h by dividing both sides by 2, you get h is greater than or equal to 4, and h is less than or equal to negative 4. So again, in terms of graphing that on your number line, you have your negative 4, your positive 4, closed circles, shading in opposite directions. For the first 2 graphs on your number lines, they're just points. There's no shading left or right for the solution. Okay? So we had a warm-up like that the other day, just continuing to reiterate, review, and go back through those previously learned concepts. So, when graphing absolute value inequalities, it's just like graphing an absolute value graph, but with shading and dashed or solid lines. So you look at the example, and that 2 is kind of like being on the inside or outside. So that graph is the same as y is greater than or equal to the absolute value of 2, absolute value of x minus 3. So it still represents our slope, it represents my stretching, and it tells me the direction the graph is open. So this graph has a vertex of 0, negative 3. That 2 tells me it's going to be stretched by 2. So my graph is going to be solid. And y is greater than, so we're going to look at our vertex and determine where are the y values bigger than my vertex. It's going to be inside the absolute value or outside the absolute value. So you plot your point, 0, -3. Remember, it's an absolute value, so my graph is a V. So we're going to go up 2 and over 1 to the right. But I conversely go up 2 and over 1 to the left as well. So from each of our points, we go up 2 right 1 or up 2 left 1. And that pattern continues on both sides, thus creating my V. Absolute value is a V. So the y values need to be greater than my absolute value. So in this case, they're going to be inside. So the y values are greater than the vertex inside. You can checkpoint that the same way we checkpointed points for linear. So maybe I take the point right there. So that's the point 0, 2. So if I take 0, 2 as a test point, I'm just going to plug it into my absolute value. So my x value is 0, my y value is 2. So I get that 2 is greater than or equal to -3. 2 is in fact greater than or equal to -3. My test point is true. My test point is where my shading is. That means my shading is correct. Make sense? Number 5, we have y greater than the absolute value of x plus 2 minus 3. So you have to identify your vertex. Your vertex comes from H and K. So my vertex is -2, -3. Remember, it's always the opposite of what was inside the absolute value. So that means that my graph went left 2 and down 3. My slope is 1 over 1. Now this time, y is greater than, but not equal to. Therefore, my line is dashed. And once again, you need to determine when are the y values greater than the vertex. So they're greater inside the vertex. And you could test point if you need to. So just like before, we graph linear functions when we solve for y. We graph absolute value functions when we solve and isolate our y variable. So in the case of this problem, my y value is not isolated. So I need to get the y value alone. So I'm going to subtract 3 from both sides. And then divide everything by 2. makes this equation y less than or equal to, dividing that absolute value by 2 is kind of like identifying a slope of -1/2. Like, it's not inside, it's outside, or in front. So that makes my vertex, let's do 5, -3/2. So you would go right 5 and down 1.5. And my slope is -1/2. So that tells me that this graph is reflected. So it means it's going to open down. And then it's also compressed because of that 1/2. So it's going to be open, down, and wider. So from that vertex point, I'm going to go down 1 unit and right 2. Down 1 and left 2. Because it's less than or equal to, my graph is solid. And then y is less than or equal to, so you go from your vertex and you determine where are the y values smaller, or smaller here, which is inside. Okay? Subtract 2. Now, here's where you have to really know your rules. You divide by a negative. What happens to the inequality, Alex? Yeah, the inequality is going to change direction. So when I divide this by -1, that inequality changes direction. Slightly better even. Alright, so now we start with our vertex. So you go left 3 and down 2. It's negatively reflected. So that means it's going to open down. Sorry, left 3 is left 2. It's open down. My line is dashed. Plastic candy on this board. Do I shade in or out? Out this time, right? Because it's y greater than. So the y's are above my vertex. Outside. I don't know. Just when I thought thought I was getting good at the board. I did some crazy ones. I know, see, different shade of reason. Alright, your homework is the next page. You have like 12-ish minutes to work on it. There are only 8 problems, so if you're already done. I go louder than you